So with that, I will now switch to English, as I said. So as my history teacher once said, no presentation is complete unless you refer back to history in some way, right? So the first thing I want to talk about is the evolution of artificial intelligence. Artificial intelligence as a field has started around 1970s. In the early decade or two, has been dominated by these knowledge-based systems that required a set of domain-specific experts to formulate a set of rules that are based on logic and whatnot. Basically, for any field, somebody had to sit down, think about how to algorithmically formulate a set of rules, a set of logical statements that then describe features that are manually designed so that the computers can actually repeat those things when they see similar problems. So if you look at the AI systems of today, they're very, very different than that. And there is a fundamental reason for the difference is the increase in data and the computing power. And majority of the AI systems today are essentially driven by what we call deep learning. And a set of deep learning algorithms. And these algorithms can handle massive amounts of data, as we know, and they can automatically learn from data. In other words, not an expert needs to sit down and essentially define a set of rules, logical statements, etc., for these algorithms to work properly. So that's a huge change. So the paradigm in that regard has shifted from these building blocks of logic-based systems to data-driven systems. And they can handle vast amounts of data because they are architected in a way, in a highly hierarchical way that can actually operate with millions of learnable parameters. So that's great. What does that mean for today? We have these systems and these algorithms are becoming prominent in almost all the industries that we can imagine. What I'm going to try to do in the next few slides is just show a few examples of application of AI technologies, application of deep learning and other machine learning algorithms to a variety of industries by giving some examples of the kinds of technologies we're developing at Park. Of course, healthcare is one of the beneficiaries of AI, I would say. So here I have two examples of AI technologies in the healthcare space. On the left, we've developed an intelligent nurse assistant. This essentially is a database and a set of algorithms that can keep track of workflows in a hospital environment for nurses. So where the patient is, what room they're in, what their condition is, when they have been seen last, when they're going to be seeing next, by whom, what kind of medication has been prescribed, what stage of the treatment they're in, et cetera, et cetera. And all of these things essentially builds a massive database from which these intelligent assistants can help optimize the operation of the nurses. And it's been proven very, very effective. We've deployed this in various different healthcare service providers in California. And on the right, we have another technology we call Fiddle, which is targeted at health and wellness for people. So it's a consumer app that works with a social network or a network of individuals, and it couples them with two different facilitators. One is subject matter experts. These would be like dietitians, nutritionists, exercise specialists, and people of that nature, as well as an AI coach. So the AI coach essentially complements the experts, and again, the back end of the algorithm is fueled with data about a person's eating habits, exercise habits, sleeping habits, and a bunch of data that you can imagine that we get from our smartwatches and iPhones, etc. And it integrates all of that together to make recommendations facilitating behavioral change that would then lead into improvements in health and wellness.
People 35 years old and younger are moving to cities, where they now represent more than half the urban workforce. This generation thinks differently about transportation. They're looking to simplify their lives and be more environmentally responsible. As active participants in this sharing economy, they're flexible about how they get around, taking advantage of both public transit and private services, such as car sharing and bike sharing. This demographic drives tremendous growth in urban mobility. Private mobility services continue to spring up in cities around the globe, but growth has been fragmented with little coordination among providers and is confusing to citizens. But what if public and private providers of mobility services pulled together into a unified, convenient, and regulated system? What if Xerox could develop a mobility marketplace for cities and metropolitan regions around the globe? Imagine offering a mobility subscription to city dwellers that integrates different modes of transportation seamlessly. A service branded by the city, operating on a single commerce platform with free data exchange. A mobility app will offer options based on individual preferences for time, cost, and lifestyle. Here, the subscriber wants to visit the Museum of Contemporary Art. The app offers options that combine bike share, train, and car share, and can be categorized by health, speed, or cost. Here she selects the cheapest route and agrees to pay the $12 fee. Her route mapped out, she will access bike share, board the train, and unlock the car door all with her smartphone. Linda, who is part of her pooling network, is already on the same route with a car. The app allows our subscriber to cancel the last leg and ride with Linda to save 3 minutes and $4. Transportation suppliers will be able to organize services in real time to provide on-demand mobility to customers. Carpooling can be facilitated for commuters traveling to the same place at the same time. City administrators will optimize existing transportation infrastructures, plan public transit routes, bike share stations, and other resources to reduce congestion and improve efficiency.
And again, example of a technology in the smart cities context that provides urban mobility services to city dwellers. And on the right, I have another example, which is a different technology that we have developed for the police departments of cities that looks at, again, data about parking violations and essentially helps the parking enforcement agencies operate better and thereby essentially write more citations and tickets so that they can maximize their revenue. Another area is AI for the enterprise. So we've been looking at technologies that looks at fraud, waste, and abuse. We particularly looked very closely in the healthcare domain. This is essentially the network or ecosystem of different stakeholders. You have the doctors and the hospitals that provide the healthcare services. You have the insurance companies as well as the Medicare and Medicaid, as we say in the US, which is the social welfare program and whatnot. And there's a lot of paperwork and there's a lot of process that are susceptible to fraudulent activity and a massive data set of literally millions of patients and millions of transactions that you can actually mine via artificial intelligence algorithms to detect fraudulent behavior and fraudulent activity. And on the right, we have a pretty recent new technology that we've been developing, which is an intelligent conversation agent that is geared for enterprise workflows. So imagine having an Amazon Echo-like or Google Home-like device sitting in your office environment that helps you essentially do your work with you in a much more efficient way. Another area that we're fairly active in is in digital manufacturing. So I have two quick examples from that space. Here on the left, we have developed a set of AI algorithms that learns how manufacturing experts plan production operations, and that gets then codified into a set of algorithms which speeds up the manufacturing planning process drastically. Something that would normally take weeks is now attainable in a matter of seconds, as you've seen in the video. And on the right, we have one of our AI technologies in Industry 4.0. Again, vast amounts of real-time data coming out of a factory environment, and a lot of things can go wrong. Many components, many processes, and now today we are able to monitor that in real time and do exception handling if something were to go wrong. If you're waiting for new material to arrive, if some of the components fail, etc., you can actually detect that immediately and react to it without any interruptions to your operations. And last but not least, AI for industrial IoT. This is a fairly active area at Park as well. So we have been developing both sensing technologies as well as a set of algorithms and smart algorithms that enables us to make systems much more intelligent and smart. So on the left, you see a rail system. Basically, we've worked with different subsystems: the doors, the point machines, the tracks, and you can sense different things about them. Again, in real time, and use these algorithms, which are really fast, to be able to detect and reason about different things. What you see on the bottom of the slide is essentially defects that are on the rail tracks, which is very difficult for human eye to detect, but you can apply visual analytics algorithms and be able to very accurately detect those things in real time. And on the right, another technology that we've been developing for deployment of these custom sensor arrays that can detect gas leaks, in this case methane gas leaks, and it's a huge problem in the US, and you can deploy these low-cost sensors on your infrastructure and on your pipelines, and it gives you the ability to detect things before it gets catastrophic in nature. So lots of different industries and lots of different machine learning and AI technologies that changes how we perceive the world and how we can take the data and reason about it and make decisions and drive value. So what does all this mean for tomorrow? If you think about this, there is not going to be shortage of more data. In fact, every single day we're generating more data than we can handle. In almost all the industries, we saw the 2.5 billion smartphones, and think about Internet of Things and smart fridges and smart thermostats and smart cars and everything, right? So the amount of data that enables us to do these things and the computational power that enables us to do these things will continue to exist, and it's going to continue to increase. Computation, on one hand, is subject to Moore's law, so it's going to get faster, clearly. And data, as I said, is going to get more as we have more and more devices that are sensing their environment and publishing data about themselves. So what does that mean for tomorrow? So if you really pose that question, you kind of end up in this dilemma of levels of automation and AI. So where would that lead us? If you really take it to the extreme, these algorithms will get smarter. They can learn things. There's data. Again, there's computation. And we can kind of imagine a world in which these smart algorithms do everything for us, and we just have to kind of sit back and kick back and let them do their job and maybe still continue to collect the paycheck. So this kind of debate is pretty hot topic these days in the US and the Western world of the impact of AI and the levels of automation for jobs and employment, what that means. And what this chart shows on the left is different industrial sectors, and on the right, ignore the circles for a minute, on the right, the automation potential. So if you look at that, the top four, accommodation and food services, manufacturing, agriculture, and transportation and warehousing are four industries that are highly susceptible to job loss due to levels of automation and AI. So that's really interesting. But my argument is, it's not about just this, the ability to automate. You have to look at what it is that really gets automated. And this chart tries to show that. In all of those sectors, there's different kinds of tasks that needs to happen, from management to expert-based tasks to data collection, data processing, and predictable, physical activities. And if you look to the right of the chart, the kinds of jobs that are likely to get lost are those that are focusing on collection of data, processing of data in the first place. Think of paralegals, for example, which has to scan a bunch of legal documents. There's patterns of data and text and whatnot. That is easy for a computer if you have enough data to codify those things and build algorithms that can kind of replicate that. Geographical services that some of the real estate agents provide in the US, the same thing. You just need geographical data and a set of things. You build a giant database. You can build algorithms that can do that. And then the one that's most susceptible to automation is predictable physical jobs. So that's the kinds of things that you see in an assembly line, welding operations and soldering and food preparation and packaging and those kinds of things. Whereas unpredictable physical environments and unpredictable physical work is actually safe, given our current technical capabilities. So this kind of paints a really somewhat scary and concerning picture. But let's continue to think about this notion of computation and thinking about beyond pushing computation. So what I'm showing here is a self-driving car. I believe it's a Ford Uber car, and I believe that bridge is in Pittsburgh, Pennsylvania. And it's been on a wonderful sunny day on a very nicely marked highway or road that actually the AI agent or the AI driver can handle. My argument is, unfortunately, the world is not always as simple as that suggests. So let's just think about these two examples. So it's easier to drive on that bridge, but if you take the same car and the same algorithm and put it in that intersection where there's tens of people that may or may not be following the traffic rules, certainly would be a much bigger challenge here in Istanbul, and a set of cars, or this foggy weather and a winding road that is not marked at all in a country road. So can the same set of algorithms handle those two situations? And most likely not. And that's because, again, the data and the cases that these AI algorithms see, they're all sort of statistically based at some level. So the algorithms essentially can reason about what they see, but what they see does not necessarily represent the complexity that the world has. So then sort of continue thinking about this notion of computation. I think there's an inherent limitation to how much you can automate simply by pushing these AI algorithms to be faster and more accurate. So the conclusion from all of this is that the future of AI and the future AI algorithms should be able to handle unstructured, unpredictable environments and be able to reason about non-repetitive set of tasks. And that's a very, very difficult thing to do. So what does that mean? Again, the previous question was, are the jobs or the human element in all this going away? My argument, or our argument at Park, I should say, is the future of AI is not going to be about the machines. It's going to be about the humans and machines as a team. Let me talk more about that. So this notion of human-computer collaboration was a big theme at Park, and it's a big part of our history. We invented human-computer interaction and a bunch of things that really resulted in interaction of humans with computers and whatnot. And there is a spectrum of views in this space. On the left, you have Polanyi, basically says, we know more than what we think. Some people call that tacit knowledge. What that really means is there are things that we cannot simply explain, but we do know, meaning that they cannot be codified in a computer algorithm. And on the right, you have the other extreme that says, we're gonna arrive at super intelligent, meaning our brains will be completely merged with computers, and we're gonna be leveraging all the intelligence that you can think of. But the common theme across the spectrum is this notion of growing partnership of humans and computers are necessary for information growth, economic progress, personal freedom, and creativity. And that comes from a very simple notion of the fact that computers are better at certain things and humans are better at other things. So let me talk more about that. So here's a sort of a simple plot. On the x-axis, we have the problem complexity. And on the y-axis, we have the solution effort, how much effort it takes to actually come up with a solution to a problem. So this is typically how AI and the computers behave. Basically, as I've shown in the self-driving car example, they cannot handle above a certain complexity, but they're really good at throwing computational power at problems. You know, with AWS, cloud computing and everything, if you don't have enough computational power, just spin another one, and then you get, you know, as much computation as you want. So they can search over these formalized spaces and millions of data, but they cannot go over a certain level of complexity. Humans, on the other hand, are quite the opposite. They cannot throw as much computation. We all get tired, and there's fatigue and those kinds of things, and there's a limit to human abilities for both cognition as well as computation, but we can do a lot of things with what we call expertise. Human intuition is really, really good in solving really, really complex problems. And typically, the more expertise we have, and that's the difference between novices and experts, the more complex problems we can handle. So then the question of where is the sweet spot, if you actually superimpose those two plots, there is an inflection point. And if you actually can follow this curve and design next generation AI algorithms in a way that would then be consistent with that black line, there is typically no limit to the kinds of complex problems you can solve with reasonable amount of computation. And that's what we're trying to do as we think about new AI systems or AI systems of the future. So again, repeating what I said earlier, it's not about machines simply replacing humans. That will happen in certain industries, in the kinds of things that I mentioned in the earlier slides. So I'm not disputing that will not happen. But the future of AI will be about human-machine interaction and the collaboration for both societal impact and economic prosperity. So what that means is we need to basically rethink the science of AI and be able to design these next generation AI systems in a way that would meaningfully put humans and computers together. And that's what we started to work on at Park. So one of the first things you have to do is you have to make AI systems explainable, meaning that they would be able to tell a human why they actually arrived to a particular answer or a solution. Meaning that, you know, here are the different things I considered, here are the things that I ruled out and didn't decide to go forward with, and this is the solution that I came up with at the end, and here's what I think that's right. So it's extremely important because that's essentially what builds trust between humans and computers, which is, again, really, really important if you want to enable this kind of world where human-machine collaboration goes to completely a different level. So we started working on this project for the Defense Department in the US, and the application domain is drones and UAVs. And what we have is a fully autonomous drone that has its own navigation system that can decide for itself, and a human operator collaboratively working to actually achieve a set of objectives and targets and tasks. And what we're focusing on is not the accuracy of achieving the objectives. What we're focusing on is on the collaboration between the humans and the machines here. And that's, again, that's a very difficult thing to do. The first thing that we're trying is to be able to go back and forth smoothly between the kind of information that computers represent and the human brain represents. So what does this all mean for the future? As I said, Park as an institution has been with AI from the very formative years. In fact, this is a book cover that's from the very early years of AI when the term was coined. And then there are names on the blocks, and the names that are in a box essentially are people that have worked at Park in those formative years. So we actually pioneered significantly the field of AI back when it's first formed. People like Alan Newell, John McCarthy, Danny Bobrow, and others have worked at Park, some of them until recently, to really think about the AI. So and we continued doing that, not only in the formative years, but throughout until today. What does that all tell us? So if the ultimate AI goal is human-machine collaboration, I would say what those early researchers had set out to do, which is a better AI, essentially some people call this general AI, meaning human-level intelligence, achieving human-level intelligence, and the quest for that is still continuing. And the capabilities that we have today compared to the past and early years have significantly changed. Hopefully I have given you at least some data points in various different industries, how these applications and how these capabilities are helping transform and disrupt a number of different industries. And we are working on today's AI technologies at Park. In fact, about 25% of our workforce is just working on AI and machine learning technologies. We have a full lab called Interaction and Analytics Lab that is dedicated to AI and AI applications and technologies. So that's wonderful. But where we're going, again, is not about pushing the limits of computation, but it will be about enabling integrated human-machine collaboration. And we're very excited to actually have started to work in that direction. We feel comfortable that we would actually do some groundbreaking research and to be able to invent a new science of human-machine collaboration. And if I were to end with a speculative note, I would say that would be the foundation that would ultimately lead to merging of AI with the human brain. And that's all I have. I'll be happy to take your questions now. Thank you.
Çok teşekkür ediyoruz.
Ben
Ağzınıza
teşekkür ederim.
sağlık. Var mı salonda efendim sorusu olan? Burada önde bir... Elinizi kaldırmaya devam edersiniz arkadaşlar. Heh. Bir de size varacağım. Başka sorusu olan var mı? Elleri göreyim. Evet, epey var. O zaman siz arkadaki beyefendiye vereceğim. Buyurun.
Miray Sağır, Herbalife. Öncelikle Tolga Bey'i kutluyorum.
Teşekkür ederim.
Yeni görevin hakkında. Sorum şeyle ilgili, yapay zeka konusunda Hawking'in ve Bill Gates'in açıklamaları var. İşte insanlığın sonunu getirebilir gibi. Bunlar işin magazin tarafı mı bizim gördüğümüz, yani konudan daha uzak olan insanlar için? Yoksa doğruluk payı var mı? Yani sizin sunumunuzda daha farklıydı, onu gördük. O yüzden soruyorum. Sizinki daha optimistik bir bakış açısıydı o sebeple. Teşekkür ederim.
Evet. Güzel bir soru. Çok sıklıkla da karşılaştığımız bir soru. Tabii ki söylemeye çalıştığım o spektrumda hangi noktada bulacağız? Mesela oradaki kitaplardan bir tanesi The Rise of Robots'tı. Bu otonom sistemler, robotlar ya da AI agentları o kadar akıllı hale gelecek ki tamamen dünyayı kontrol altına alacak ve biz hiçbir şey yapamayacağız tarzı teoriler elbette ki var. Ama umuyorum ki sunumda da bahsetmeye çalıştığım gibi verdiğim örneklerle aslında o noktaya gelmeden önce o kadar kompleks problemlerle karşılaşacağız ki giderek çözümün o yöne doğru ilerlemeye çalışmaktansa insanlarla AI algoritmalarını bir araya getirmek olduğunu göreceğimizi düşünüyorum ve onun üzerinden gideceğimizi düşünüyorum.
Bir de herhalde hani her konuda yetenekli ve zekası çalışan insan olmadığı gibi her konuda yetenekli ve çalışan yapay zeka da olmayacak. Biraz böyle spesifik. Kevin Kelly'nin The Inevitable kitabından biraz kopya çekmiş gibi olacağım ama yani ben böyle spesifik yapay zekalar olacağını düşünüyorum. Mesela üretimde çok iyi çalışan yapay zeka, güvenlikte çok iyi çalışan, savunmada çok iyi çalışan. Ben de heyecanla bekliyorum. Buyurun, burada bir soru vardı.
Evet, merhaba Tolga Bey, Joseph Çıprut Kantar. Öncelikle tebrikler, çok ufuk açıcı bir konuşma oldu. Size sorum şu, biliyorsunuz IBM geleceğini cognitive computing üzerine koydu. Microsoft da aynı şekilde cognitive services'ten bahsediyor. Cognitive ile AI sizin için aynı şey mi? Aralarında bir fark var mı? Sizin Amerika'dan bu konuda bakış açınız nedir diye sormak istiyordum. Teşekkürler.
Ben teşekkür ederim. Güzel bir soru. Cognitive Computing ile AI birbirleriyle alakalı ama aynı şey değil. Ama en son bahsettiğim projede bahsettiğim gibi Human Computer Collaboration'ı eğer gerçekten yakalamak istiyorsak bir şekilde Cognitive computing üzerine de çalışmamız gerekiyor. Çünkü insanlarla makinelerin birbirleriyle iletişimin kesişim noktalarından birisi insan beyninin nasıl çalıştığını daha iyi anlamaktan, onu modelleyebilmekten ve bilgisayar algoritmalarla insan beyni arasında gidip gelebilmekten geçiyor. O yüzden IBM'in olsun, Microsoft'un olsun o alana yatırım yapması açıkçası bizi şaşırtan bir durum değil. Bu dediğimiz alandaki bilimsel gelişmeleri hızlandıracak ve istediğimiz noktaya ulaşmamızı sağlayacak yatırımlar olarak da görüyorum ben bunu.
Teşekkür ediyoruz. Arkada bir soru vardı, onu dinleyelim.
Merhaba, çalışıyor mu? Esat Belhan ben. Ben de tebrik ederim sunum için ve göreviniz için. Benim sorum aslında biraz teknoloji dışı, biraz yani bu anlattıklarınızı kapsayacak şekilde.
Sanki uzun olacak gibi de bir ürperdim.
Okey, evet öyle gibi başladı. O zaman
süremiz doldu çünkü.
tamam, kısa
Buyurun.
halini sorayım. Çok kısa kısmını sorayım. Gelecek aslında insan ve yapay zeka arasındaki işbirliğinde diye bir sonuç çıkardınız. Yanlış anlamadıysam. Bu durumda biz teknoloji geliştirenler olarak şunu mu söylüyoruz? Biz evet pes ettik çünkü hiçbir zaman insan zekasına teknolojiyi eriştiremeyeceğiz mi diyoruz? Yoksa kısa vadede eriştiremeyeceğiz, o yüzden mecburen böyle bir vizyon koyuyoruz mu diyoruz?
Evet, güzel bir soru. Şimdi şöyle, dünya veya evren de diyebiliriz. Onun kompleksitesi de statik değil. Bugün yaşadığımız dünya ile daha önce yaşadığımız dünyanın kompleksitesi arasında da çok büyük bir fark var. Demeye çalıştığım şey teknolojinin hiçbir zaman insan beynine erişemeyeceği değil ama evrenin ve dünyanın da bir şekilde evrimsel olarak kendi kompleksitesini arttıran bir olgu olduğu ve o kompleksite içinde doğru çözümleri yakalayabilmek için insanlarla makineleri, insanlarla yapay zekayı bir araya getirmenin daha doğru bir strateji olduğunu söylemeye çalıştım.
Hesap makinelerinin icadından sonra hesaplamayı bırakmadık değil mi?
Evet.
Devam ediyor. Çok teşekkür
Ben
ediyorum.
teşekkür ederim
Başarılar
tekrar.
diliyorum.
Sağ olun,
Gururla
teşekkür-
takipteyiz. Kolay gelsin.